right, so Bob, full disclosure here as we get started, okay? What I'm teaching you today is I'm giving you a little bit of a Calc 2 experience at a university. Okay?
I'm scared.
They do this stuff, and you got to do it with ease. It does take us about a whole class period to do 3 problems.
Oh.
Because I'm trying to teach it to you, remind you of a few things, all this stuff. Here we go. All right. Hopefully, when you're really good at it, you can knock it out a whole lot faster than that. But Baba, we just got to talk about a few things. Okay. All right. So Baba, are we doing long division on this thing?
No.
No, because the power on top is less than. If they were the same or it was greater, you'd do long division, but it's not. So the only thing that I can think about, we're not completing the square with that. Completing the square is only with quadratics, so none of that business. We got to factor this, right, Baba? It's like, Baba, if you pull out an x, you'd be at like x squared minus x minus 6. But what does that factor out even more to?
Minus 3x plus 2.
Yep. So factoring this out completely, you would have x, x minus 3, and x plus 2. We have factored our denominator completely. Now, somebody did ask 4th period, like, Mr. Breaker, shouldn't you check to see if the top factor is 2 to see if anything cancels? Absolutely. Please do that. But I'm just letting you know right now, nothing cancels. Okay? If you could, like, simplify, Joseph, you know what I'm saying? Yeah. You should simplify. But today, nothing simplifies. All right? So we have to be able to integrate this. Now, a little different than yesterday. Just kind of get us warmed up right here. This is, how many linear factors do I have?
Trace.
3. So you would do the same thing. You're like, Mr. Springer, I know how to do this. This would be like a over x. It would be b over x minus 3. And all of a sudden we have a c now over x plus 2. And again, we would set that equal to this expression, right, over our denominator. And we go, we get busy, right? We're ready to go. Baba, what did we do after this step right here?
We use the cross multiply.
We used to cross multiply, but there's 3 of them. But it all just kind of goes back to, do you know how to do common denominators, right?
Yeah.
Algebra 2 stuff. If this has an x, what does it want?
Those 2.
It wants those 2. So you are literally going to have an a, x minus 3, x plus 2. What does b want?
X and x plus 2.
Yeah, you're going to have an x and a x plus 2, right? C wants an x and a x minus 3. And once you get common denominators, we don't pay attention to them anymore. You just set it equal to that numerator over there, and we're ready to start solving. All right, so Bob, what did we do yesterday after we got to this step?
We would plug in an x.
Right, that's cool. Right, so let's try that. Right, you would say you want to do x equals 3.
Yeah, sure.
Right, so if I did x equals 3, this goes away. That goes away. You're going to have what right here?
X equals 3 times 5, 15.
Okay, Baba, is it really easy to screw something up?
Very, I can tell.
Okay, there's a lot going on right here. Just slow down, breathe. Don't be one of those people that has to do the problem like 10 times. You know, they just trust your math and go with it. All right, so Baba, I plugged 3 in over here, right? 3 squared is 9, 9 times 4 is 36, 36 minus 12 is 24, 24 plus 6. Looks like B is 2. Right? You cool with that?
Yeah.
Daniel, what do you want to do next?
Let's plug in -2.
So if we plugged in -2, that goes away. That goes away. Daniel, what do you get?
You get -10c equals, or sorry, 10c.
10c, right? Because you got -5 times a -2, which is going to be like 10c equals, all right, over here.
So you got 16 plus 8 plus 6.
Which is
You get to 30.
30. So c is 3. And with all my experiences too, like in college, Daniel, if you're getting some like weird numbers, you know, like if you were this whole time getting like 1/7 and 3/5, you know, it doesn't happen very often, right? Like especially in college when you don't have a calculator in any calculus course, if you're getting nice whole numbers, usually you're doing it right. You know what I'm saying? Usually you're doing it right. All right, so what about this next one?
0.
Huh?
0.
0, right? Like if I plug in 0, right? That goes away, that goes away. What do you have over here? If you plugged in 0, you get -6? Luke, you follow me?
Yep.
If I plugged in 0, you get negative 3 times 2, which would be like negative 6a. And if I plugged in 0 over there, it equals 6. So a is negative 1. Porter, what do you think?
Makes sense.
Okay. So Porter, let me just write these down for 1 second. Right? I know A is negative 1, B is 2, C is 3. Now Porter, I'm going to show you just another algebraic approach to this, because it might get you out of a bind here and there. Kind of like I told 4th period, I remember Huntley Peck liking this approach. Huntley liked this approach. So Baba, here's my question. What happens if I just call this like x squared minus x minus 6 right here, right? And I distributed the A. Right? You cool with that?
Yeah.
Right? You can put this so many different ways, doesn't matter. But you know, I just distributed the A. You cool with that?
Yeah.
What if this was like x squared plus 2x? You get what? You can call this so many different things. 2bx, right? Technically, you put the variables at the end, right? And all this fun stuff, but that's 2 variables right there, so we'll get. You cool with that?
Yeah.
Porter, you got that? Okay. Porter, what about this next one? What happens if we distributed?
CX squared minus 3CX.
Okay. All right. Now, why do we do that? Because one, this can get complicated. You'll see here in just a moment what some examples might look like. But Porter, what do you think I'm going to do with all of these? What do you think I'm going to put in parentheses right here? A plus C? Can we do all the x's?
Yeah.
Let's do all the x's. So I'm going to put an x out here. What do you think I'm about to put in that parenthesis?
Negative A plus B.
Plus
Oh, plus 2B.
2b
Plus, or minus 3C.
minus 3c. Right? What's left over? Negative 6a? All right, why are we doing this? Why are we doing this? Come on. Patterns. Where are we going with this, Baba? What are we doing here?
Baby.
You have to make it a thing.
Huh?
You have to make it that.
But what are we essentially maybe like making here a little bit? What do you think I'm going to set A plus B plus C equal
4.
to? 4.
A
Why?
system of equations.
Systems of equations. I'm literally going to do A plus B plus C and set that equal to
4.
4, right? If I did A plus B plus C and set that equal to 4, that's cool. I would set all of this equal to negative 4, right? And since this is the only thing out here as a constant, I can just set it equal to 6. See what I'm saying, Porter?
Yeah.
Now, Porter, this one worked out pretty nice for the most part, because you could solve for A right now and do what?
Negative.
Right? Is that what we got from before?
Yeah.
That's cool, right? I could take negative 1 and plug it back into these equations, for example, Porter. Like if I plug negative 1 in here and added it over, I'd have A plus B equals what? 5,
B plus C.
right?
Plus C.
Oh, sorry, B plus C, my bad. B plus C equals 5, right? And if I plug negative 1 in here, it's really positive 1, but when I subtract it over, I would now have 2B minus 3C equals negative 5,
Yeah.
right?
You could, yeah.
And then what? What were you going to say? Substitution.
Multiply by negative 2%.
What do we call that? Solving systems of equations by elimination. Bob, you remember doing that?
I do remember that.
Bob, what would you do to this top equation?
Multiply the negative 1.
Negative 2,
Or negative 2.
right? Because the negative 2b and 2b's cancel.
Yeah.
You would have negative 2c and negative 3c, which is negative 5c. Negative 10 and negative 5 is negative 15. Did we get c as 3 earlier?
Yeah.
What do you like, Porter?
The first one.
You like the first one? That's cool. You haven't seen the other 2 example problems yet.
This one better.
Huh?
This one better.
No,
It's better when we get more.
I'm just giving you some tools for the trade here.
What do you like?
Okay, okay, next.
I like whatever makes sense to you.
What would you use personally?
I prefer this way.
This way?
Yeah.
Oh, so you do that every time?
Takes the guessing game out. In a lot of ways.
So example two.
Alright, so Porter, once you got A and C, could you like just come up here and plug it in? Right, you can plug C in for 3, it's -1, you can solve for B. I'm not gonna go through that. You cool with that, Bobby?
Yeah.
Alright, so Bobby, let's finish this problem.
Charles.
We haven't even finished it yet.
That's the funniest thing I've ever
Do
seen.
it.
So Bobby, we did all this work, and we're ready, right? So we're gonna integrate basically -1 over x. Then we're gonna do 2 over x minus 3. And then we're gonna do 3 over x plus 2. And then you're like, Mr. Baker, we've been doing this all day. It's great. Baba, what do you get here?
Oh, you get natural log.
Of x. Right? What do you get over here?
Natural log, 2 natural log. of
2 natural log of
X minus 3.
x minus 3 plus
3 natural log of x plus 2.
C. Right?
All that's is value bars.
And yeah, don't get yourself to the bars. Don't worry about trying to add or subtract because they don't really have common denominators or common factors right here. So you're done. You just leave your expression like that. Okay. Porter, what do you think?
I want to see example two.
You want to see example 2? All right, let's do it. What does example 2?
Not yet.
Mr. Baker, you said there's no calculators in college calculus?
Yeah. You go to any major
Cool,
university.
you literally are a
There's no calculators.
You don't
Like
need a
zilch,
freaking-
nada, never.
Don't make
I don't
me-
even know why the EP exam that you use them is stupid, but that's just it.
Oh, shoot.
Sorry, college board. Okay? You just don't need to use them.
How much?
Why? Because they want your calculus and they want your algebra to be.
I don't need it yet.
Yeah, I mean, it makes sense.
Yep.
They don't
Alright.
need- They don't need people that can push.
Example number 2.
This is all exercise.
See, man, like if I could just go back in time to honors algebra 2 years ago and
Oh, yeah.
when people didn't like Mr. Baker because he was so hard, and I could just like flash forward to a lesson like this and be like, told you so. But you know what I'm saying? I
You're gonna
can
break his vote?
If only Mr. Baker.
I'm pretty close to that.
Yeah, that's what I'm saying. Like you guys all, yeah, honors algebra 2 back in the day. All right, please tell me for the love, do you guys remember how to factor the bottom?
I do.
So,
You gotta break
Oh,
it.
Factor by half.
Oh,
It's a
yeah.
fact, break it in half,
Two halves.
and then
That
And
was in the
what's this
Henry.
called?
so,
No soap, no difference in cubes.
Those in
No
A?
soap in cubes.
I don't know. what it's
Factor
called.
by.
Parts.
They don't call it that.
Chunks.
halves.
wrong direction. Pieces.
It's factoring by grouping.
I said chunks.
Chunks.
Close enough.
Is that what your math teachers used to
Ew.
do? Chunks and parts?
wait.
Yeah, there was this guy that was teaching algebra 2. I don't.
Oh, really? Yeah, Mr. Baker never said that. Alright guys, we're gonna do it in chunks. Alright, we are gonna do factor by grouping. And,
By chunks.
right? Remember, if you don't remember how to do that, you group the first 2, you group the last 2, you pull out GCFs.
Is that a difference?
There is a GCF of -1 right here, so it changes the sign. If you're not getting the same parentheses right here, we got a problem. You're not doing factoring by grouping correctly. Baba, do both of them have an x plus 1?
Yeah.
So it's like you pulling out another x plus 1, and what are you left with?
And where are you itching?
Right? If you pulled out another x plus 1, what would you have?
X squared minus 1.
You'd have x squared minus 1,
Oh my
right?
gosh.
We factor that. Now, Baba, just for fun right here though, does this go even further? What does that turn into?
Scratch your hand for
X plus 1, X minus 1.
Okay.
That's a lot of X plus 1s.
Oh, wait a
Right?
minute.
So factoring the denominator completely would give us this new integral right here. Factoring the denominator completely gives us this new integral right there. Now, this is different than well, like Miss Baker, we just did one like this with 3 linear factors. That's cool. But what you didn't have was repeated, right? You've never had repeated linear factors before.
I see the issue.
Okay?
You plug stuff in, they're gonna all go there. Yeah.
All right, so Bob.
I don't
Baba.
see that issue.
That was an
A
intelligent
lot of people,
sentence.
a lot of people would start off by saying, you know, a over x plus 1, right?
It's just X minus
Now-
X plus 1.
Sorry, x minus 1. X minus 1, right? I wrote that backwards. Yeah, whatever, doesn't matter. All right, I'm gonna do the linear factor first right here,
Okay.
because you'll see why. But it doesn't really matter at the end. So I did x minus 1 first. Now, Baba, technically I know this is x plus 1 squared. okay? But a lot of people might forget this middle term out here and just be like, Mr. Baker, I did it, right? I did my constant over my linear factor, my constant over two linear factors, that's it.
You have to put a B with it, don't you?
But there's this middle term right here. What's the denominator of this middle term?
X plus one.
It's just x plus 1. Right? Because technically, could I multiply this expression by another x plus 1 and I'd have the same denominator right there?
Yeah.
Yeah.
Don't forget about this one. Right? If you ever have linear factors, repeated linear factors, do the singular one, maybe the double one, the triple one, whatever, right? You gotta have a constant for each one. Because you can still get a common denominator by just multiplying this by x plus 1. And we're good to go. And with that, Baba? So there is a b in this case, right? And we would set that equal to that expression over there, right? You get your 2x squared plus 3x minus 7,
It's plus
7, right? And you got your,
Wait, Mr. Baker,
what's it?
Me as well.
why is C over x plus 1 squared?
Yeah.
Because technically, I do have x plus 1 squared here as my denominator,
Yeah.
right? But how many ways could you get a denominator of x plus 1 squared? You could have it just like this, or you could have a denominator of x plus 1 and still get a common denominator of x plus 1 squared, because you're going to see here in the second quarter. What do you think this a wants?
X plus 1.
It wants an x plus 1 squared.
Yeah.
But what do you think the b wants?
X minus 1 and x
Plus 1.
Yeah.
and then C.
Right? The b wants an x minus 1 and an x plus 1, because the x plus 1s would give me an x plus 1 squared. You got that, Porter? When you have repeated linear factors, you gotta do like the singular case, the double case, the triple case. We did the singular case, the double case, you know what I mean, if you had repeated linear factors. Just because you're gonna miss out on an opportunity right here to maybe solve for b. Because there are other ways to get a common denominator of x plus 1 squared. Okay? Now, what is the C1?
X minus 1.
C1's an x minus 1, right?
Oh my god.
Right? Okay? Now, let's do it. You want to do it the old school way? That's fine. I don't care.
No. No.
Wow, this is a new
No, a lot of people like the old school way. I'll do the new way next, probably. Okay.
Oh, jeez.
Okay? So, Baba, what are you going to let x equal?
Negative 1.
-1. If I let x equal -1, that goes away. That goes away. You get -2c equals 2 minus 3, which is -1. -1 plus 7, 6. I got c of -3.
Yeah.
You cool with that?
Yeah.
Porter, what's the next value of x you want to use? Huh?
If you do 1.
I like 1. If you chose 1, this would go away, right? That would go away. This would turn into what?
Yeah,
4a, right? And if you plug 1 in over here, you'd have 2 plus 3, which is 5. 5 plus 7 is 12. So a is 3. Cole, what do you think? Now, here's where you just might, this is kind of like the guessing game, but it's not a bad guessing game on this problem. What's a fun number to pick? That's always a fun number to pick for any kind of thing.
Zero.
Zero. Just let x equal 0. If you plugged in 0, you would have a. If I plugged in 0 right here, technically you'd have a -1 times a 1, which would be -b. And if I plugged in 0 there, you'd have -c, and that would all equal what? 7. Do you already know a and c?
Yes.
Yeah.
You already know a and c. You could literally go 3 minus b plus 3, that's 6. You subtract the 6 over, you get -b equals 1, b equals -1. Yes, Andrew?
So essentially, is there any, I guess you need to cancel out. Wait, you don't need to do any, you can just throw any number in there, can't you?
Technically, you can throw any number there,
Okay.
but I think 0 is the easiest.
Yeah.
Yeah.
So if it's like a third power on the bottom denominator on these integrals, is there always going to be an a, b, and a c then?
Yes.
Okay.
For each of those linear factors.
Yeah.
That are repeated. I'm not going to do it to you because that would be a lot.
So there's as many like A, B, C constants as there is a degree on the bottom.
Just wait.
Oh no. Oh no. That's not very reassuring.
Just wait. Okay? We ready?
Yeah.
Alright, so doesn't this turn into
We're not even.
what? 3 over x minus 1? We got negative 1 over x plus 1, and we got negative 3. Alright, Bobby, you cool with all that?
Yeah.
Alright, so this is again, everything's just kind of starting to pile on here. Don't mess it up. Is this 3 natural log of x minus 1?
Yeah.
Right? Is this a negative 1 minus the natural log of x plus 1?
Yeah.
What do you have to do there, Baba?
You gotta use up.
U sub, right?
Yeah.
You got a U sub. You look at that and you're like, Mr. Baker, U is x plus 1. Du is going to be dx. I got the dx part. The negative 3 technically lives out in front. So when you integrate 1 over u squared, Baba, how do you integrate 1 over u squared?
You add 1 to the power.
We'll bring it up top.
Up top first.
So it's u to the negative 2. You add 1 to the power and stick it on the bottom, right?
Yeah.
So really you have a negative 1 and a negative 3, which makes this a positive 3 over u on the bottom. But what was u? Woohoo!
Good times, just regular good times.
These aren't good times. Wow. Good times. I think Owen likes these problems. Owen, do you like these problems?
Why are you? You're like so uneven.
Wait, well, hold on.
You're like how we played last year.
Owen's over there doing double integrals.
Try to show me one.
So he's doing who?
Like, what is that?
Okay.
Yeah, I was like, I've never seen this before.
Dude, I'm already on my like second.
He used to slide me challenge problems
Yeah,
for
this
physics,
one's
and then he got in trouble.
Oh,
We
and
take calculus.
you still working on your
physics.
custom physics problems over there?
Baba, I like these problems because they're algebra heavy. And if you can do all of these steps and never screw up once, you're gonna be fine in like differential equations when problems fill up the whole page. Here's like differential equations is a big time algebra.
Yeah.
Can't say that.
Big time algebra.
Big thing.
Okay? Alright?
I'm actually a big time out.
Alright, last one here, Baba.
Where are we?
This one packs a little punch. Okay?
It's sneaky because you have to have the code for me to
Henry does not like it.
Whoa, that's another.
Henry, you don't have to let
Alright.
him do that.
Okay?
I think we should factor by chunks.
That should be fine.
minus x squared.
Yeah, I was.
2x cubed. You got it. Just want to see if you guys are paying attention.
Factor by chunks.
Thank
Alright.
Factor by chunks.
Alright, so we are going to factor by grouping. Right?
Factor by
Hopefully
chunks.
you already know how to do that. You pull out a GCF, you're left with 2x minus 1. You pull out a GCF of 4, you're left with 2x minus 1. And lo and behold, your integral turns into something like this. Okay? We factored it out correctly and boom, you get there. Alright? Now, Baba, what's the difference between this integral problem and any other one that we've done so far?
We have a by no even degree in the denominator.
We have a
Quadratic in the denominator. We have a quadratic factor in the denominator.
right? We do. We have a quadratic factor down here in the denominator.
That's not fun.
Well, we'll talk about it. Alright, so Baba, here's how this works.
Okay.
Alright? You have a over your linear factor. Right?
Yeah.
A over your linear factor. You did hear me briefly mention yesterday, A is always like 1 power less than the linear factor, right?
Yeah. Oh.
That's what it represents, right?
I see. We're gonna have a b
So
squared.
when I do this one, right, I have x squared plus 4 right here.
Mr. Mayor, I don't think you said that just now.
I
You
did.
say that.
I did.
I don't remember that.
Let's run back
Or
to
it like happens
Yeah.
fast. Like briefly, I was like,
Run back to tape.
notice that they're 1 power less.
Do not,
Yeah, we got video
run back
evidence.
the tapes.
Okay? Alright, so Porter. Porter. We gotta be one power less.
BX.
BX is good. But like, just with anything, when you integrate or something, right? What could there be out there?
A pussy.
A constant.
Oh, heck no.
Okay? There could be a constant out there. You don't know. But there could be.
You don't know.
What if we have another term, then we do like B subscript C, like plus some
You have
letters?
26 letters in the alphabet. Hopefully you're not doing a problem that long. If you do, you pull out a matrix, a computer, and go to town with systems of equations.
Hans would use ChatGPT.
He's not denying it.
I think if ChatGPT tried to
Okay,
do that,
all right, so, Baba, you cool with that?
ChatGPT would
Right?
respond with
If
a
you ever have a
comment.
quadratic factor, you do have to have a two-parter up there. The x plus c, right?
ChatGPT would say, I don't know.
All right.
I'll be like,
Wait,
"Damn
that's
you."
C is in integration C, not C is
No, it's just, it could be a constant out there.
It's just a
Right.
C.
That's what I'm
Cole.
saying.
She's more than one type of
Zach, why did
C.
you just, why
really
did you
hope
just
that's
rip
audible in
during
the tape.
this class? Ew, Zach, that smells so bad.
All right, so here we go. Ann, you ready?
I've been ready.
Oh, okay. All right, so we have our setup here, Baba, right?
Yeah.
Basically, we're back to like cross multiplying right here. A wants the x squared plus 4, right?
Yeah.
Bx plus c wants what?
That one's 2x minus 1.
It wants 2x minus 1, and then you would have it equal to x squared minus x minus 21 right here. Okay?
Oh, jeez.
So now, Baba, here's where it can. I mean, you can do it. Don't get me wrong. Like, you can do it both ways.
Yeah.
You know what I mean? Like, fourth period was like, Mr. Brinkley, let's plug in 1/2. And I was like, good luck. I mean, you know what I mean? Like, I just know how some, it's.
1/4 plus 4.
That's what I'm saying. You're like 1/4 minus 1/2. You're trying to get all this right and like not screw up on a little. You can do it either way. I don't care. I'm gonna look at your paper and I can follow your algebra pretty fast, to see if it's actually making sense. You know what I mean? So, Baba. But I think you guys need to be more well versed in algebra skills.
I'm gonna
Okay.
foil my kid.
Okay? So, Baba, if I called this like ax squared plus 4a, you cool with that?
Yeah, I'm cool with that. That's what I was
X squared plus 4a. If I did FOIL over here, right? Not your little box method.
I said-
Why?
I said shoot. I said
Okay?
foil.
If you FOILed over here, you'd have like 2bx squared, wouldn't you? Right? 2bx squared. You would have a negative bx. You would have a 2cx and then a negative c as your last one. And Baba, just like we did before, just to be well versed, what did we do from this step?
We're gonna start to pull out some stuff. So
Did I combine the x squareds?
Yeah.
What goes in there with the x squareds?
A and 2B.
There you go. What are you gonna do about the x's?
We're gonna pull out some
Whatever you
of those
want.
and we're gonna do just negative B
Yep.
plus 2C.
Yep. And what are our constants left over?
Let's see, C, negative C,
And
4A.
4a, right? So you basically have like a 4a minus c right here. We're ready to go. All right.
That's why you quadratic formula.
Yeah, why is it lowercase?
Sorry,
Gosh,
Henry.
Mr. Baker.
Sorry, Henry.
It was throwing me off.
Okay. All right, Henry. What am I setting a plus 2b equal to?
One.
Right. Setting equal to 1. What am I setting negative b Henry plus 2c equal to?
Negative 1.
Negative 1. And what am I setting 4a minus c equal to?
Negative 21.
Okay. Now, technically here, you would have like a systems of equations, 3 equations and 3 unknowns. Like this one would have like an A, B, there would be no C, right? This one would have no A, but a B and a C. You can do, I'm not asking you to do 3 equations and 3 unknowns, blah, blah. You know what I'm saying? You can do this like so many different ways up here. It doesn't really matter to me. I'll just do it the first way because my finger's close to it.
Yeah.
What's the variable that's easiest to isolate right here?
Like A.
A. So like Bob, if I did A equals 1 minus 2b, right? What am I going to do with 1 minus 2b, you think?
You're gonna stick it in somewhere else.
Where else do you think I'm going to stick it in?
The second equation. Wait,
We're in
no.
calculus class, Henry.
That was not my joke.
Where-
Bob, where we put it?
Let's see. We could get over there because we could get to one variable problem.
Okay, like if I put it over there, right, Baba? I would have what? I would have 4 minus 8b, right? Minus c equals negative 21.
Yeah.
Right? If I plugged it in right there and I multiplied everything by 4, I would have 4 minus 8b minus c equals negative 21. As soon as you subtract the 4 over, you get negative 8b minus c equals a negative 25, right?
Yeah.
What could you then probably do with this equation and this
The
equation?
elimination thing.
You could do elimination, right? You could just literally put them on, right on top of each other. This is why algebra skills are so important. Right? You put them right on top of each other. We solve by elimination. What do you want to do here, Bob? I don't really care.
Multiply by 2.
On the bottom? Okay, so if I multiply by 2 on the bottom, Baba, I'm going to have negative b and a negative 16b,
Yeah.
which is negative 17b.
Yeah.
You're going to have 2c minus 2c, right? Which cancels out. And then you're going to have negative 1 and a negative 50.
51.
It just so happens that 17 goes into 51 evenly.
I mean, it doesn't.
I don't like that.
Design that way.
I also don't like this.
So b is 3.
Okay.
Baba, could I instantly come right over here and say, I mean, it doesn't really matter. You could just find an equation. You know what I mean? Like, I could plug 3 in right here.
I'd rather do it in the first one.
It doesn't, you know what I'm saying? I don't care. If you plugged it in right there, you're going to get 6.
3.
Right? So what does a equal?
Negative 5.
A is negative 5, right? And then you could come in over here and be like, you want to solve for c. So you plug 3 in again. You subtract the 3. You get negative 2. C equals what? C equals negative 1, right?
Negative.
Oh, positive 1. C is positive 1.
There we go.
C is positive 1. My bad. C is positive 1. Porter, how do you feel about that?
Good, I understand.
We still have to.
Okay. Coleman, you feel good about that? Okay. Now, you got all those numbers, Porter?
Thanks, sir.
Okay, I'm gonna save room for this next step right here. Porter, what does this integral actually look like now? We got a is what?
Negative 5.
So you get negative 5 over 2x minus 1. You get now the integral, what was b?
Yeah.
What was it? 3x
Plus 1.
plus 1?
Over x squared plus 1.
Okay. All right, now,
Do we get to do it again?
Textbook code.
Wait. No. No.
Textbook content. What I was talking about.
okay, Baba, we can do this one, right?
Oh, yeah.
Don't get lazy with u sub,
No.
right? If you let u be 2x minus 1, du is going to be 2 dx. I don't have a 2, so you divide it over. So really you have negative 5 halves
Yeah, up front.
right out in front with what's 1 over u? Natural log
Yeah, natural log.
of 2x minus 1, right? So we've integrated that stuff in our sleep for a year now. For a long time.
Yeah.
Right, David? Yeah. Okay. Now you get to this one. You're like, how do I do this?
Arctangent. So something like that.
If you let
Do it all
u be
again.
x squared plus 4,
Okay.
du would be 2x, but that's not the same as 3x. That, u substitution right there is not going to work. It is not. We're not going to. Can't really complete the square to try to do arctangent right now.
Let's do it again.
Oh my
Wait,
gosh. what's
why
the-
wouldn't you?
If we do that after doing the partial fractions and
2x
doing
and
more
3x
partial
can't do it.
fractions, I think
Partial
that would-
fractions.
Can't you just multiply both sides of the u by, or the du by 3 halves, and then it just becomes
Can't be
3x?
That ain't. Do you have to do it again?
Partial fraction
Oh, jeez.
decomposition.
There's no way there's not a faster way to do this.
Why are we doing this? Why are we doing this?
Anshul? I'm an Anshul. It was funny. I looked at O and I was like, Anshul.
Should we split it up?
Sure. What do we do?
Oh, jeez. I sure I wouldn't answer if I were you.
I'll try.
Jarun.
Bob, stop.
Let's see. Maybe we could do like x squared plus 4 divided by 3x plus 1.
Which is what?
And then multiply the top by that, and then, wait, no. We'd add to get it to look like x squared plus 4, and then we'd subtract afterwards.
Dwight.
We split it up.
What'd you say?
The old classic. You know what I'm saying? Mike,
Oh, yeah.
Getting bricks out of the bottom of the pool. What is wrong with you guys? Okay? What is wrong with you guys?
Only Henry.
Alright. Alright, so Bubba.
Alright.
Bubba. Alright, so Bubba, to finish this out, we are going to separate this integral. You got the integral 3x over x squared plus 4. And you have integral of 1 over x squared plus 4 dx. Still going to do u sub on this one, right? U is x squared plus 4. Du is going to be 2x dx, right? You got the x dx part. You just don't have the 2. So remember, this 3 lives out in front, right? This 3 lives out in front. When you divide by the 2, you're going to have 3 halves, right? 3 halves natural log of x squared plus 4. And on this one over here, this is arctangent. We did one like this yesterday. Just remember when it's in that format of a squared plus u squared. You know, we know that technically, a is the constant one, so a is 2, and u is just going to be x. So when I apply that formula, 1 over a, arctangent of u over a, you're going to get your answer right there. So this final answer over here is going to be 1/2, right? And arctangent of u over a plus c. And don't forget about this little guy over here from the very beginning. This would be your final answer right there to this problem. Very good.